Good morning, guys. Okay, I have a second conjecture for you to think about, and this time it's dealing with four-sided shapes. So I drew this parallelogram and I put one diagonal on it, the blue diagonal there, and I'm going to put the second diagonal, the red one here. So the diagonals just go from corner to corner in a quadrilateral. And it looks to me like the blue diagonal is cutting the red one exactly in half and vice versa. Is that true? Is it always true for any quadrilateral? Is it sometimes true? Is it never true? Well, even though it looks like it, maybe it's not even really true here. It's easy to show that it's not always true for every quadrilateral. Take in a kite. And a kite looks a little bit like that. And if I drew diagonals here, just by making my example a little more extreme, it's really easy to see that the blue diagonal is not cutting the red diagonal exactly in half. So it's not always true that the diagonals bisect each other. But my original shape here is a parallelogram. So it's got a little bit of extra special stuff about it, more than the kite did. These two sides are parallel to each other, and these two sides are parallel to each other. If I add that restriction in, then is it the case that the blue diagonal bisects the red diagonal? Let's think about that for a second. Okay, if I could show you that these two triangles are congruent to each other, they're the same shape and size, then that blue piece must be exactly the same size as that blue piece, and this red piece must be exactly the same size as that red piece. So if I could show you that, then it would be true that the diagonals bisect each other. So because this is a parallelogram, I know this side and this side are the same length, right? And they're parallel to each other. And if I think about my parallel lines theorems, the opposite angles on parallel lines are the same. Let's call this angle A and this angle A. And then let's call this angle B and this angle B. So the opposite angles inside that set of parallel lines with the blue transversal, the ones I labeled A, they'd be the same angle. And the ones that I labeled B would be the same angle. So now I have two separate triangles that have one side length in common, and the angles beside that side also in common, and that's enough to prove that those two triangles are congruent to each other. If the two triangles are congruent to each other, then the sides are all the same length. Congruent means the same size and shape, right? So this side indeed is the same length as that side, and this one is the same length as that one. Okay, so now I can start to use that idea in questions like the textbook questions that I assigned, where they said, hey, if this diagonal is 5 centimeters, how long is this one? They're the same length, so it's 5 centimeters. And how far is it from A to B? Well, it would have to be 10 centimeters, right? 5 plus 5. The length from A to B is 5 plus 5, which is 10. Right, so as long as I know that it's a parallelogram that I'm dealing with, the diagonals indeed bisect each other. Have fun, guys.